few weeks ago, a friend of mine sent me this article by a climate change denier called "The Climate War's Damage to Science." And as a scientist, I took a step back to ask, am I doing damage to science? But first, I want to ask another question. Why is there still a public debate about the very existence of climate change? I think one reason is that the climate is a chaotic system. And when we talk in normal everyday conversation about chaos, we use it as a synonym for randomness. But it's not, when we're talking about it in a scientific context, we don't mean that a chaotic system is random. And so I'm going to illustrate this with an example. Think about an eddy in Boulder Creek, and imagine dropping 2 leaves at the same starting point in this eddy. And initially, they would travel with each other around that eddy in parallel. But over time, one of those leaves might go over and loop off on the other side, and the other one might hit a part of the whirlpool that's moving faster, until the 2 leaves that started at the same point were on opposite sides of the whirlpool from each other. This is a classic characteristic of a chaotic system. It's very, very difficult to determine the exact path of these leaves. So what we do is we take a step back. We look at the long-term time lapse of this eddy, and you can see that there's places in this whirlpool where you're more likely to find leaves at any given time. There's trends that you can take out of this chaotic system, even though the trajectories are really hard to determine. And this is the same property that climate science has. So when you look at one run of one model of the sea ice extent, it looks really bumpy and bouncy and ragged, and you could even say it looks random. But what we have to do is take that one trajectory and back out and to look at all of the trajectories. And you see this trend. And the trend is really clear. The long-term pattern is very easy to see. So, to review with you guys, climate is chaotic. Chaos means that predicting things in the short term is really hard. Determining an individual trajectory is hard. Being able to tell you what the temperature is going to be in 10 years during your political campaign, really hard. But in the long term, it's much easier to do. In the long term, we know what direction things are heading. So let's go back to my first question. Am I doing damage to science when I talk about climate change? So when you look at this picture of the California drought, I think many of us are tempted to say, this is caused by climate change. And if you say that, you are doing damage to science. That is not what the science says. In fact, the climate science says that over time, we should be seeing California getting wetter over time. So this drought in California has been going on for 3 years. And it's clearly an extreme weather event. And I think those of us that live in Boulder and support climate science and understand that this is an important issue want to say that this extreme weather event is an example of climate change. But we can't actually say that. There's a different explanation in this case. And I think we have to be careful with how we talk about these things, especially because we're up against skeptics and climate change deniers. In this instance, the California drought is actually caused by this high pressure system off the coast of California, and it's pushing all the precipitation to the north. This is something that's actually happened before. And it's really, when you look at that high pressure system and try to figure out what caused it, if you take all the different kinds of models, the models of the human impacts, and the models of the sea surface temperature, and the models of just natural variability, the natural variability has most of the causality for these changes. So we need to be really careful when we talk about this stuff. At the same time, we recognize that these systems are really complex, that we're not dealing with a single eddy in the stream. We're dealing with hundreds of eddies over hundreds of years and trying to make predictions about these really chaotic systems. So when we talk with climate change deniers, climate change skeptics, people who haven't made up their mind, they might say, you know, can you be 100% sure that climate change is going to happen? And the answer to that question is, are you 100% sure that climate change isn't happening? Because if you're not 100% sure, then the time to start making changes is now. Thank you.